Hello, I'm Frank, and in this video, I'll teach you the basics of Linux bash scripting or Linux shell scripting. Let's go for it step by step. I'll teach you the basics, and if you want to learn more, check out the link below. Did you know you can automate Linux systems? So you can, with one single program, you can make it do all kinds of things, whether that's things with files, with the internet, anything that the Linux system can do, you can automate that with shell scripting. In this video, we'll take a look at shell scripting. So a shell script is simply a list of commands or a script that it does those commands automatically. And of course, you can use all kind of programming logic. Now, just to be sure, we are using Linux. So if I type this command, you'll see we are on the Linux system. Of course, this works on Mac as well. On Windows, you have different commands, so it doesn't work. So if you want to automate Linux, you can use this course. So let's start with the first shell script. You can use any editor you want, whether that's Nano, Vim, or anything else. So I'm going to type Nano. Then we create a new file and we end that file with the extension .sh. So I call it example.sh. Then on top, we add a line that indicates that this is a shell script. So that's this line. And that indicates that we are actually using the Linux shell. Now we can type one or more commands here. So we can type a command like echo hello world, and we can save it. Ctrl O, enter, that saves the file, and Ctrl X, we quit it. Now before we run this script, we need to make this executable. So if I take a look at the permissions, you'll see there is no X for executable here for this file example.sh. So we need to add the executable permission, and we do that with this command, chmod +x example.sh. And then if we take a look at the permission, we see that X there. And that X means the program is executable. Now to run it, we simply type /example.sh, enter, and we see the output hello world. So it just run the shell script. And in the shell script, we have this command echo hello world. And of course, if you just run this as a single command, it does the same thing. So by typing this command /example.sh, it always runs that command. This is just a single command. It is not limited to a single command. You can run as many commands as you want. So now that we've written our first script, let's make things a bit more interesting. Let's do a bit more than saying hello. We're going to store information, and to do that, we use variables. We can ask for user input and show some response to that. So let's start with a simple program where the program will have a name, and then we will print that name. So we're going to start a new example. Again, we'll have a bash script. Then we're going to ask the user, or let's first define it. Let's say we define a variable with a name, and then we can simply output it, say echo hello, and then we reuse that variable we defined here. And to do that, we type the $sign followed by the name. That's how Python or Bash knows that this is a variable. So we save it, Ctrl O, Ctrl X to quit. Now we make it executable with lowercase x. Press enter, and we can now run it. And you'll see it outputs hello followed by my name. Now if we check the code, you'll see in here we defined the variable. We can also get this from the keyboard. So we could say, what is your name? And then read that name. Instead of defining it, we read it from the keyboard. So we can say read name, save it, quit, and then run it. So it asks us our name. You can type it, and based on that variable, the variable name, it then outputs it. So we output that line, what is your name? We read the variable name, and then we print it. Remember the $sign to print the variable. So when reading it, we don't use the $sign, but when printing, we use that $sign. Now, of course, this can be anything you read from the keyboard. So you could ask another question like, what is your favorite Linux system or favorite system? And you can then read that and then output the favorite. Now if we save it and run it, you'll see it first asks our name, and then the favorite system, and you'll see it then uses both variables to put them on the screen. Now, because they are variables, you can also reuse them. So we don't have to do this line here. We can say hello $name, and then the rest of the line. So you can read variables first and then print them together, $name, $sys. We save it and run it. We can then print it, and you'll see it outputs them both. So those variables don't get lost. They are like stored in the computer memory, and you can reuse them as much as you want. So here we reuse those two variables, even though we read them sometime earlier in the code. You can make your program interactive and use keyboard input, use some quote-unquote AI. So to do that, we're gonna create a new program. So I'll call it linux.sh. We tell Linux that this is a bash script or a shell script with this line. So this line on top, we make sure that it's a shell script. Then we're gonna ask a question. So we say, are you a Linux user? Now that question can either be answered with yes or no. So we ask the user, so we're gonna read from the keyboard. We simply type read, and we store the answer into the variable answer. This can be any variable. So if you want, it can be X or Y or simply answer. Then based on the variable, in this case, the variable X, we can do different behaviors. So we can say if, now very important, we have this block quote open here, and there must be a space then. So if the X, and again a space, is equal to space yes, and then the end quote. Now see all those spaces, those are very important in bash scripting or shell scripting. Otherwise, it's gonna be not working. And also we use this double equality sign. So then we say Linux user found, and V to end the program. So Ctrl O to save, Ctrl X, we make it runnable, and then we run it. So if we type no, you'll see it does nothing. But now watch if I type yes, and you'll see now it does that behavior only if you type yes. And this is an if statement. So given an input, there's a choice made. So given this input X that we read, if X is equal to yes, then it outputs that, or then it runs whatever commands are here. Otherwise, it does nothing. Now, it might be sometimes you want to catch both cases. So then you can say else, and then that's the case when there's not a Linux user, because in this case we check for that question. So if we save it and then run it again, and we type no, now it tells us not a Linux user when we type no, and if we type yes, it tells us it's a Linux user. So based on input, in this case we read it into X, and the program can give completely different outputs. So this is called if statements, and they're used everywhere in scripting and programming. Let's say you want to check more than just a yes or no. You can deal with that using the elif keyboard. So for example, if we remove all of this, we could ask the user, what is your favorite car? What is your favorite car, for example? So we're going to read from the keyboard and read into the variable car. And then if that variable, now remember the spaces here, if that variable car is equal to, for example, Porsche, then we can say you like Porsche. But for the other case, we could keep going. We could say elif, then the car is equal to Ferrari. Then we could say like Ferrari. And we can add more cases like this using this elif. So we can say car is equal to Opel. And then let's add another choice. And then when you're finished with all of this, you could add a fy. So now it supports multiple inputs, not just yes or no. Now keep in mind we added lowercase and uppercase here. So let's make all of that starting with an uppercase. And let's say we run this program and ask the favorite car. So let's say you type the first one, it does the first else. Now if we type the second one, you'll see we have multiple optional input now. Because we use this elif statements, we can capture multiple cases in the same if statements. So you're not limited to yes or no questions with bash scripting.